We're going to measure the NOx to determine when we need to run our DEF fluid. We have a module specifically set up to measure NOx and communicate that information back to the PCM. The NOx sensor module is mounted to the vehicle frame under the body. It controls the NOx sensors mounted in the diesel after treatment exhaust system, downstream of the selective reduction catalyst and diesel particulate filter. So it's going to see the NOx after we have passed through the selective reduction catalyst. It communicates the PCM via a special CAN 2 to report NOx and O2 concentrations, as well as sensor and controller errors if it has a fault. Here's the actual NOx sensor as it's plugged in here, just to this side of the dosing nozzle. The NOx sensor is used primarily to sense O2 and NOx concentrations in diesel exhaust gas. The sensor is mounted in the diesel exhaust pipe. It's mounted downstream of the FCR and it interfaces with the NOx sensor module directly to report the amount of NOx detected after we've gone through the SCR. When the NOx is too high after leaving the SCR, it signals we need to start dosing to reduce the NOx in the exhaust system. So here's our NOx sensor right here, as you can see it close up. NOx is very hard to get rid of once it's formed. It's formed when we have combustion at high temperature, where we have oxygen and nitrous oxides that combine together to form oxides of nitrogen. It doesn't like to break apart. It needs to be reduced or reducted. One way to break it apart is to do something that will compete with the nitrogen for the oxygen molecule. We need something that is so hungry for oxygen it strips it out of the nitrogen oxide and makes it nitrogen, and then makes water vapor or water. Urea is injected into the exhaust stream to do exactly that. We call it our exhaust diesel fluid, diesel exhaust fluid, whichever way you want to put it together, sometimes shown both ways. In the presence of the catalyst, which is heat in this case, this urea is going to turn into ammonia, and the ammonia reacts with the NOx to create nitrogen and water vapor, N2 and plus 3 H2Os. We've been using the EGR to reduce NOx, but starting in 2010, the amount of reduction we could get out of EGR was not enough, so we had to add the exhaust fluid. It removes the NOx that was created and formed in spite of being reduced by the EGR. So NO is 1 oxygen and 1 nitrogen atom. NO2 is 2 oxygen atoms and 1 nitrogen atoms. During combustion, undesirable yet unavoidable nitrogen oxides are produced that can't be helped. Ammonia, NH3, is introduced and metered into the perfectly balanced NO2 to neutralize each other. So we're going to break this. Ammonia is going to come in and break these two down, so we get rid of oxides of nitrogen. There's more than one. 65.7% water, 32.5% automotive grade urea. Urea is a compound of nitrogen that turns into ammonia when heated. It is a nitrogen already. It's going to be breaking the nitrogen down. That's why it takes it away from the other nitrogen. So now we have all this information about our regeneration and ammonia level for selective catalyst reduction.